So welcome everybody to 6.2. This is Solving Quadratic Equations, which is now an extension of last chapter, chapter 5, where we were learning all the strategies for factoring. So first we're going to talk about what a quadratic equation is. And if you remember this from the first unit, chapter 4 of quadratics, it's ax squared plus bx plus c. And now we're looking when it equals 0. So just keep in mind that a, b, and c are real numbers, and that a cannot equal 0. So the other thing that we're going to look at then are roots. So what the roots are the values of the variable that make the equation true. These are also known as the solution of the equation. So if you had an equation that had brackets like we've seen factoring before, and it equals 0, which is what this quadratic equation is going to equal now, in order for this to stay a true statement and to equal 0, either this one can be 0 or this one can be 0. So when we're solving, we can set each of these equal to 0 and we'll find our roots. So in our first example, we have to solve for x, and we'll check the solution just for the first one. So we have x squared minus 16x plus 63. So in order to be able to solve for when it equals 0, you could try to start rearranging, but notice you have two x's here that are not like terms. So the only way to actually solve for it is to factor. Now, if we go back to our strategies from before, this is a simple trinomial because there is a 1 in front, which means we can go right to the shortcut where we can draw our skeleton. And so x squared is our first term, so x has to be in the front. And we are looking for two numbers that multiply to get 63. Those same two numbers have to add to get negative 16. So if you click pause now, give yourself a second to try and figure that out. And hopefully you came up with the numbers of negative 7 and negative 9. Now, what does this mean in order to solve when it equals 0? Like we said before, if this bracket is 0, 0 times x minus 9 will still give 0. Or if this bracket is 0, 0 times x minus 7 will also give you 0. So we can set each bracket equal to 0, x minus 7 equals 0, and x minus 9 equals 0. So if we rearrange this now, x equals 7 and x equals 9. And so those are solutions to this equation. We'll check just one of them. And the checks that we've done before are left side equals right side. So our left side, and we'll go back to the original one, is x squared minus 16x plus 63. And our right side is 0. So if we sub in, let's say we're doing 7, we have 7 squared minus 16 times 7 plus 63. And so we have 49. So I've just done some math off to the side, but negative 16 times 7 is negative 112, and then we still have plus 63. And if we add all those together, we get 0. And so our left side equals our right side, and therefore the solution that we came up is a true statement. So now we're going to try the next one. 6x squared minus x equals 15. So I'll just write that below. And if we're going to factor this one, in order for it to factor and to be able to solve, our equation needs to equal 0. So to do this, again, this doesn't look like the quadratic equation. But if we rearrange so that we have 6x squared minus x minus 15, there's nothing left on that side, so it must equal 0. Now we can actually factor it because it's in the quadratic equation form. Looking at the first coefficient here, this makes it a complex trinomial. So whichever strategy you would like, you could do product sum, so multiply the 6 times the 15, or you could do and say that the sum is negative 1, or you could do the box method. So I'm going to quickly do the box method. So 2x, 3x, multiply to get the 6x squared. Then we have negative 15, so let's try negative 3 and 5. So that gives negative 9 here, multiply across, negative 9x plus 10x equals positive 1x. We want it to be negative, so we're going to make this one negative and this one positive, and then that fixes it. So factored, we have 2x plus 3 and 3x minus 5 equals 0. And to solve, just like before, we set each bracket equal to 0. So we have 2x plus 3 equals 0 and 3x minus 5 equals 0. So 2x equals negative 3 divided by 2. So right now we're just doing our equation solving, so it's negative 3 over 2 for this x. 3x equals, bring the 5 over, do the opposite operation, and then the opposite of 3x is to divide it by the 3, so it's 5 over 3. So the solutions for this quadratic are x equals negative 3 over 2 and x equals 5 over 3. Those are the solutions that will make this statement equal to 0 and be true. The last example I want you to look at is on page 277. It's in 6.2 of your book, and you're going to look at that example 3. It's looking at a word problem where you have to solve with the area equals length times width. It's just like the second example we did. If you have any questions about it, though, make sure you write them down, bring them to class, and maybe we'll take it up together. Have a great day, and this is just a shout out for Connor. See you in class.